Three fair kinds are thrown. Write out the sample space S. Okay, let's suppose that the first kind thrown shows heads. Then there are two possibilities for the second kind. The second kind could be heads or it could be tails. So if the first kind is heads, the second kind could be heads or tails. So we could have heads, heads, or heads, tails for the first two throws. Okay, let's suppose that the first two throws are heads, heads. Then there are two options. We could either have heads, 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 or heads, heads, tail. And similarly here, we could have heads, tails, heads, or heads, tails, heads. So that's four different outcomes. Now let's suppose that the first throw shows tails. Then the second throw could either be heads or it could be tails. So we could have tails, heads, or tails, tails. If we have tails, heads, then the third throw is heads or it could be tails. If we have tails, tails, the third throw could be heads or tails. So we have another four outcomes. In total we have 8 outcomes. And we can always work out the number of outcomes by using the fundamental principle of counting. There are two ways that the first throw can appear. It can be either heads or tails. And for each of those two ways, there are two ways for the second throw to appear. So by the fundamental principle of counting, there are 4 ways for the first two throws to appear. And for each of these 4 ways, there are 2 ways for the third throw to appear. So by the fundamental principle of counting, we multiply the number of ways together to get 8. So we know that the number of elements in the sample space is 8. The number of outcomes is 8. In part A, we are interested in the probability of getting 3 tails. So we look to S and we find the event where all the outcomes consist of 3 tails. Well, the event just consists of a single outcome. So this subset of S has only one element in it. So to get the probability of 3 tails, I'll write 3t to indicate this event here. We put the number of elements in this set, which is 1, over the number of elements in S, which is 8. Just 1 out of 8. All these outcomes are equally likely. We have no reason to believe that any particular outcome is more or less likely than the other outcomes. We're dealing with 3 fair kinds, and the throws are independent of each other. So if we throw heads in the first throw, it's not going to affect the probability of throwing heads or tails on the second throw. Similarly, the second throw does not affect the third throw. The result of the second throw has no bearing on the probability of getting heads or tails on the third throw. The probabilities are always 1/2. So we're dealing with independent trials or independent throws of kinds. What is the probability of getting exactly 2 heads? So we look at all the outcomes that consist of 2 heads. I will call the event getting exactly 2 heads 2H. So the event 2H occurs when one of these 3 outcomes occurs. To get the probability of this event 2H, we just count up the elements in it. We see that there are 3 elements in it, and we divide by the number of elements in S, which is 8. Now let's look at the probability of getting at least 2 heads. Let's look at the outcomes that consist of at least 2 heads. Well, it's all the outcomes of the previous part plus the outcome consisting of 3 heads. So here it is. At least 2 heads means 2 heads or 3 heads. And we can see that there are 4 elements in this set. So the answer is 4/8, which is 1/2. We could think of this question another way. We could say that the probability of getting at least 2 heads is the probability of 2 heads or 3 heads on our kinds. So we have an OR situation. One event or another event. And these events are mutually exclusive. If we get exactly 2 heads on a coin, then that excludes the possibility of getting 3 heads. And if we get exactly 3 heads on a coin, of course, that excludes the possibility of getting exactly 2 heads. So these are mutually exclusive events. And we saw from a previous video that when events are mutually exclusive, the probability of the union of them, or means we're getting the union of these two sets, is the sum of the probabilities of the two events. So we're dealing with two sets here really. One set consists of these 3 elements, and the other set just consists of this one element. So these two sets are disjoint, they have no elements in common. So these two events are mutually exclusive events. The probability of getting exactly 2 heads is just the number of elements in this set here, which is 3 over 8. The probability of getting 3 heads is the number of elements in this set, which is just 1 element. So again, as before, we get 4/8. Now in part D, we want the probability of getting exactly 1 tail or exactly 1 head. So I'm going to call those two events 1t and 1h. So I will just indicate the event 1t. So all outcomes in here just consist of 1 tail. Now let's look at 1h. Well, here is an event consisting of 1 head. So the event 1h has these 3 outcomes. This is 1h. So these two sets are disjoint, so we are dealing with mutually exclusive events. So we can just consider the probabilities of these separately and sum the probabilities. The probability of 1t is 3/8. The probability of 1h is 3/8. So the sum is 6/8, which is 3/4. Of course, we can just count the number of elements in the union of these two sets. You can see that there are 1, 2, 3, 4, 5, 6 elements in the union. So there are 2 ways to look at it. So when we're getting the union, the probability of the union of 2 events, what we do is we take the union of the 2 events and just count the elements in them and divide by the total number of elements in the sample space. Now in part E, we want the probability of 1 tail or at least 2 heads. Let's look at the event where the outcomes consist of 1 tail. So here it is here. I can call this event 1t. Now, but what about the event at least 2 heads? Well, we saw that earlier. We saw it in part B. I'll just indicate that. I'll just call the event at least 2 heads 23h, meaning 2 or 3 heads. It's nothing to do with 23. So what we do is we take the union of the 2 sets, the red and the blue set. Well, the union of them just consists of 4 elements. So the answer is 4 divided by 8. If we want to talk about mutually exclusive or non-mutually exclusive events and just look at the probabilities of the 2 sets separately, well, we see that these are not disjoint sets, obviously. The intersection of them consists of these 3 elements, HHT, HTH, and THH. If we want to use the methods of a previous video where we looked at the probability of the union of 2 sets, which is something we do when we're interested in getting the probability of one event or another event. Well, the full expression for it, as you saw before, was probability A union with B equals probability A plus probability B minus the probability of A intersecting with B. So that was the general statement. So let's just go through this problem this way. We know the answer is 4/8, but let's just look at these separate probabilities. The probability of getting the event at least 2 heads is 4 over 8. That's this probability here. The probability of the event which is getting exactly 1 tail, is 1, 2, 3 over 8. And we subtract off the probability of the intersection of the two sets. So the intersection of the two sets consists of just 3 elements. So you see that again we get 4/8.